It is also today we'd like to share how to determine the equation of a plane containing 3 points. As we all know, for any plane, there must be a normal vector attached to it. So what we have to do here is to determine two lines vector so that we can compute the normal vector. To have two lines, what we can do here is by taking this 3 point and fix a starting point. So we fix A as the starting point. Then let's say in the left hand direction we will have B, and the right hand direction we have C. So from here we already fixed the starting point and we form the line vector. So for the first line vector, let's say is A to B. So always use the end point minus the start point. We can write in vector form. So we obtain 0 minus negative become plus, minus 1 minus 1 we have minus 2, 2 minus 0 we have 2. Then for the second line vector, the endpoint is C. So 1, 3, 4. Minus starting point, which is minus 2, 1, and 0. So we obtain 1 minus negative become plus. So we have 3 here. Then 3 minus 1 is 2. Then 4 minus 0, we have 4. After we obtain the two line vectors, we can form the normal vector by taking their cross product. In other words, it's actually finding the determinant of the two lines vectors. So we have component I, J, and K. I to represent the X component, J represent the Y component, and K represent the Z component. So we'll fill up. We have 2 minus 2 and 2. Then we have 3, 2, and 4. When performing the computation, we have to be careful as the cofactor with coefficient of plus minus sign alternately. So what we have to do here is always be careful. When we take the component I, it should be plus sign, then followed by minus. For the component J, then a plus sign again for the component K. So when we take the component I, meaning to say we will cover the row and the column, and we left only negative 2 times 4 to get negative 8, and we minus 2 times 2, which is 4. So we proceed in this manner for J and K. So we have 2 times 4, which is 8, minus 2 times 3, which is 6. Then for K, we have 2 times 2, which is 4, minus negative 2 times 3, which is negative 6. Then we do some simplification. We have minus 12i. 8 minus 6 is 2. So times negative minus 2j. Then we have 4 minus minus become plus 10k. So in vector form, we have negative 12, negative 2, and 10. Okay, now let's proceed to form the equation. We have a common point which is A. So we have negative 2, 1, and 0. And we dot with the normal vector negative 12, negative 2, and then this will form the equation. We just replace the normal vector with the component I, j, k to x, y, z. So we are negative 12x minus 2y plus 10k. So we solve for both sides. So we have minus 2 times 12 plus 24 plus 1 times negative 2 minus 2, 0 times 10 equivalent to 0. So this will give us, we bring everything to the left hand side. So 12x minus become plus 2y minus 10z. So we have 24 minus 2, which is 22, equivalent to 0. As we can see, all the coefficients here are even number. So we divide both sides by 2. So we obtain 6x plus y minus 5z plus 11 equal to 0. Then we done. So this is the equation of the plane that contains these 3 points. Okay, that's all for today. Thanks for watching. Hope you like this. See you.